He is a tenured faculty member at NC Central's Neuroscience program and Department of Chemistry and Biochemistry. He also has a joint appointment with UNC Pharmacology and Duke Pathology. Please welcome Dr. Somnath Mukhopadhyay.
Good evening. So my postdoc was supposed to give the talk. He got ill, so that's why he is. No, seriously, this is me. This is me. And Alicia put this picture, but I keep this picture floating around the social media just to remind my wife time to time, please don't stress me. I lost this. I lost all of it. Okay, just to keep it. So I actually going to talk to you about something that you all are consuming right now here. So don't blame me. I will give you a solution too. So yes, my talk is say no to booze and pot, because I'm working on this area for the last 20 years, starting in the Midwest in St. Louis. But in the Central Campus or even Chapel Hill, everybody knows my lab as a booze and pot lab. So students are initially very interested to join my lab every year. And I'm saying no, but let me get into that, what it is all about. We know all about that recently, or for the last 30 years, in the university campuses and all around, the people are consuming. Our adolescents, college goers, are consuming alcohol and cannabinoid that we call the pot in different ways. So the question is that there are a lot of studies has been done with the adult, but my group is particularly interested to know when you are consuming cannabinoid that we call the pot or marijuana and alcohol together, even at the subthreshold level, over the weekend, at your adolescence, what happens to your brain? And whether that effect sustained. So we developed a model that we call the cannabinoid receptor agonist. This is the antagonist, and I will not go into the details. Basically, this is we call the AIE, adolescence intermittent ethanol and adolescence intermittent cannabinoid. That means it mimics what happens in the dorm scenario. So basically, people consume 2 days, then couple of days gap, then again 2 days. So we develop this model in the animal, and these are the animal's date, adolescence period. We give them 2 days on, 2 days off for at least 1, 2, 3, 4, 5, 6, 11 doses. And then we did some behavioral study. And then we kept them to grow all the way to the adulthood, and again did the behavioral study. And these behavioral studies are related to some learning and memory behavior. And you will see yourself that what happens here, and then we try to find out by sacrificing them to see, can we find out what happens in their brain? So basically, we are asking this question, that whether this AIE or AIC alone or in combination cause any effect in the adult brain, or whether this treatment changes their behavior in the hippocampus area, that is the regions of the brain that controls our memory, and whether this effect persists during the adulthood, and if there is any cure or there is any hope that we can still drink, but will not lost our memory. So this is, you will see that there are 2 sets of data here quickly, and we will not go into the details. This is the behavior that we measured, where we call the spatial memory or YMS test, where you can see that this is right after the treatment, and this is the alcohol, cannabinoid, and together, and see there is a decrease. This group of animals did not get this, and there is a decrease in their spatial memory function. And when this CB1 receptor antagonist, that's a drug that I'm calling SR1, is given along with them, none of them has that impact. They maintain their behavior, or learning behavior, same as the control group. But look at this, what happened. This is very important. This happened in the age adolescent. And this is equivalent to you drink around when you are 21 to 25, and then when you reached your adulthood, then also, sorry, not 21 to 25, say 18 to 21, and then when you reach your complete adulthood, that effect persists. This is very alarming. We all have done a lot of things, good things, bad things during our college life. But this combination really has a persistent effect. So we did another type of test, what we call the novel object recognition, which is a part of the cognition, and see all of this going down. But when we have this drug along with it, this blocked this effect. And again, same thing. The same trust remain during the adulthood. And then, with this drug, this effect can be prevented. So then we sack the animals and trying to see whether that impacts the brain. This is the area of the brain where new neurons are formed. So look at this. This is the cannabinoid, and this is the drug. Marijuana caused the decrease in the new neuron formation that we fancy term is neurogenesis. With the drug, it gets blocked. With ethanol, does the same thing, or alcohol treatment. Combination does the same thing. So this drug is really giving us a hope that it can be prevented. And we measured a couple of the cell proliferation to measure whether the brain cells, different types of brain cells, growth is basically affected by this marijuana or alcohol, and whether this drug can prevent that. And we showed that, yes, this can be prevented. Combination treatment, same thing. Then we looked into something fancy we call the cell death. This is an enzyme assay. We call it ClipCaspase-3. And as you can see here, again, the same way, all of this increase the cell death in the brain, and this particular drug, when present with this alcohol or marijuana, they can prevent that effect. So based on all this, we come up with a kind of model that alcohol, and it has been proven by others, there is a group of compound that we call endocannabinoid in the brain that binds to this marijuana receptor that is present in the brain, and then it actually increases several inflammatory factors or immune factors in the brain to prevent this new neuron formation. And we can prevent that with this CB1 receptor antagonist. And we are still working on it, looking into the safety part of this thing, in particular this model. But when you have a decrease in the neurogenesis, you may have loss in the integration and alteration of the existing brain circuit and the synapse formation, which may lead to long-term learning and memory impairment. So I'm saying, have this information, ask your college goers not to drink and smoke pot simultaneously, if possible, or to avoid. But there is a hope coming in the horizon. And I hope someday I will be able to stand here and say, drink, but drink along with this drug. Thank you.
Thank you. Just say no. I remember that from being in elementary school. Who had a question over here? I'll go back here.
Here. Oh, over here. So what is the role of adult neurogenesis in the brain? What does it do? I mean, is it necessary?
Great questions. So we lost, as soon as we reach the adulthood, every day we are losing almost anywhere between 15 to 20K neuron. And it increases with the stress, different factors, when you are writing the grant, or when you forget your wife's birthday, all those stress increases. There are certain areas of the brain, though, and neuron is one of the type of the cells in our body that doesn't divide from 1 to 2, 2 to 4. There are certain areas of the brain where new neuron from the mother neuron or neuronal stem cells still generates. There are specifically 2 areas that has been proven how this 400 or 500 neuron per day can integrate with the existing circuit is a big question. Some people in the field don't think that they're important, but in the last 10 years, it has been proven that they are playing a very important role. It is more like that certain part of your house circuitry is damaged. Now you bring the new circuitry and you're trying to integrate that. So we are still learning this adult neurogenesis and its role in the addiction area or learning and memory. But definitely there are now proof that this adult neurogenesis plays a very important role regulating the hippocampal learning and memory function.
Hi,
Hi, I have a couple questions. Did you look at different timing of giving this drug? Does it have to be simultaneous with the consumption? Can it be afterwards? And also, is there a difference between if you're only having alcohol, only having pot, or is it the combination of the two that causes what you've been seeing?
Great questions. Yes, we have tested 5 different treatment exposure window and how early we can start it to have this effect. So I'm just showing you the one piece of data that is definitely we proved that. But yes, across the board, early time point exposure or individual exposure with alcohol and cannabis, there may be a little bit difference, but overall qualitatively, they produce the same effect.
I'm gonna move a little bit just to keep equity in mind here, right? We'll go right here.
You know, having lived in Northern California for 10 years, I met a lot of pot smokers, and one of the reasons, you know, why they smoke pot is because it increases creativity. Have you, you know, been able to determine that on a molecular level at all?
I don't know why you guys are laughing. I know why I'm laughing. The answer is, sir, to me at this point as a scientist standing here, it increases some of the neurotrophic factor, no doubt in it. And some people went to a long extent to prove those neurotrophic factor like BDNF, brain-derived neurotrophic factor, for example. They are released from the brain after the marijuana pot. Yes, first 4 hours increases. There is no direct proof that that will increase your creativity. That's where I will stop to say, I have no scientific proof that it increases the creativity. There is some anecdotal data to suggest that, not necessarily, but I will say only it causes more damage than the creativity.
Thank you. I think we're out of time, but I'm sure you'll stick around for some questions later.
Sure. Anybody want to ask me a question, I'll be glad to. Thank you.
Round of applause one more time. Thank you.